Today's tutorial is looking at the attribute transfer node, which is very simple in concept, but it's actually incredibly useful, and I've realized I use it in loads of my networks, often more than once. Basically because if you break something in your network, you can use the attribute transfer node to fix it up again and to tidy it. We're going to look at a couple of concepts we haven't covered yet, specifically UVs and volumes, very briefly in this tutorial, because I'd like to introduce you to the attribute transfer node before we cover them in depth. The two complement each other very well. We're also going to take a very quick look at L systems, which are extremely good fun, but in this case we're just going to use the defaults. So first of all, I want to give you a quick reminder of what attributes are in Houdini. So first of all, I'm going to create a grid node. Up till now we've always created a geometry node at the top level, but you can, in fact, if you're creating one of the basic primitives, you can go straight to grid and it will create what is effectively a geometry node, but call it grid, and then place a grid inside. So it's a little bit of a shorter way to do it. Let's increase our rows and columns. Now, if we have a look at the geometry spreadsheet for our grid, this contains a list of all our attributes. And the attributes are values that are attached to every individual component. What we're looking at here are the point attributes, and we have a lot of points in this grid because I've just given it 50 rows and columns, so we've actually got 2,500 points. And the only attribute we have at the moment is position. You can also attach attributes to vertices, which are effectively points per primitive. So if you split the points up so that there's an individual one for every face that it's attached to, these are much more useful for holding things like UVs, because you don't want all your UVs to be continuous all the time, and sometimes normal. So if you want a hard edge, you want to be able to separate them across an edge of some faces. We also have the primitive attributes, which are a bit more straightforward, and we have a detail attribute, which is slightly different. There's just one of these for every object, so it's like it's basically an attribute for the object. So let's go back to our points and we'll add some new ones. So first of all, if I drop in normal sup, this will create, by default it actually creates on the vertices. If we switch it to points, you'll see that we now have normal information. We can also create some UVs. So if we go to UV texture, which we'll cover in a lot more detail later, I would hope that you have a fair idea what a UV is if you're working in 3D graphics. So the UVs are by default also created in the vertex attributes, and this is the best place to leave them, otherwise you'll get pulling at seams where it tries to join everything up, and that's not what we want. You can also create your own attributes. So if we do attribute create, let's create a point attribute, we'll call it user, and give it a value, let's say 0.5. In fact, let's make it a vector. Let's make this 0.1, 0.9, just some random values, and make it a vector. So we've created this in points. So now we've got an X, Y, and Z value for our users, which correspond to these values we've given it. When you create an attribute, it's giving that value at every single point, but then we can start manipulating it. Let's take a look at what's going on with our plane. Not very much at the moment that we can see. If we split this into let's let's see, we don't want two views side by side, we actually want split it top bottom and then change this to a geometry spreadsheet. So now we can see both at the same time. Usually you only need to see the first few values on your geometry spreadsheet. So because it's the top line that's important. So I usually just put a little strip at the bottom to display it. Now you remember we also have the attribute VOP node, which allows you to manipulate your attributes. So here I'm going to take, let's take our position node and plug it into color, and suddenly we have a color attribute as well. And you see this corner is very dark because we're looking at negative values. We could add in our user attribute, so I'm going to use a bind node and type user, which is all we need to do to bring that in. If we do override type with input, it will know that it's a vector, and let's plug that into our color instead. Have I given it the wrong name? Ah, but we do need to set it. Now let's try adding the two together. So now you can see we've started playing around with some of our attributes. Now what the attribute transfer node does is it takes those attributes and it transfers them to another object based on their proximity. So the best way to demonstrate is to show you the simple example that you'll see in a lot of tutorials and also in the help documents for the attribute transfer node. So we're going to create a sphere. Let's make it a polygon and give it a colour that's different from the colour of our plane. So let's make this red. And now we drop in an attribute transfer node. The attribute transfer has two inputs. The first is your the object that you want to transfer onto, and this is what you're going to get out as well. The other object that you add to it, when you connect it up, you'll see it has a dotted line because it's taking attributes from that object, but it isn't actually outputting it. So if you want to see, so if we switch that on, you'll see we're now just seeing the plane. If we want to see both objects, we'll need to merge them together. And now you can see a bit better what's going on. First thing you'll notice is your sphere is turned black and the plane's turned white. These are for two completely different reasons. So the reason it's turned black is because we have a mismatch on the attributes, because this one has normals and this one doesn't. So all we need to do is hook the normals in here as well. And we're getting some odd effects because it's transferring the normals on the sphere of the sphere onto here. So actually, it might be easier just to delete them. There we go. Let's have a look at how this node works. So the first thing you've got are your source and destination group, and to be honest, I don't use this very often. It's if you were just wanting a subsection of your object to be affected, like for example, let's stick in a group node. And select it within a bounding box. So let's create a bounding box here. So now we have a small group within our object. Now if we were to, this would be the destination group because it's the destination object. If if we change this to group 1, you'll see that only that square is being affected. It's pretty straightforward, and you can do the same thing with the input group if you only want a subsection of your object to be taken into account. But for now, let's ignore that. The next, well, there's 2 tabs here, and you'll find you edit these things all the time when you're working with them, so you need to know what they mean. The first one is the attributes that you want to be transferred. If you click this, it will transfer everything on the points, so all these attributes are being transferred over. And let's see, if we stick on vertices, it should transfer our UVs as well. Sorry, the UVs are on this object, so it won't be transferring them. But if we had them on our sphere, it would take the UVs. The second tab is the fun one. This determines the distance to which things are transferred. At the moment it's set at 10. If we zoom out a bit, you'll see that there's the distance of 10. So if we drop this down to below 5, you should start seeing the edge. So now you can see that the sphere is only affecting the closest points. There's 2 ways to affect the distance. If it is a hard value, you get a much nicer effect if you change the blend width. So that will give you a nice soft blend from the value at 0, which is red, to the values that were previously on your object. The kernel function determines how the curve between each, from one colour to the next one, is affected. Most of the time I don't change this. There are very specific circumstances where you might want a sharper drop off or a more linear drop off. Let's just leave this on the default. And the kernel radius again is affecting the kernel function, and I've found the effects are pretty subtle here. Max sample count is something that you might want to play with. It's determining the number of points it's used to calculate each attribute. So the default is 1, so it's basically looking at the closest point to this point and taking that colour. If you ramp up the default, then it will be looking at a collection of 7 points around that area and taking the average and using that to transfer. A lot of the time it won't make any difference, but I'll show you in our example later where it can make a difference. By default, the one attribute that isn't matched, even if you actually plug it in, it won't do anything. So you can add a value here, and that will eliminate all the other values and just look at what you've added in. If you leave it blank, it will look at everything. But position isn't making any difference. However, there are situations where you would want to do that. So let's have a look at, if we hit the P value, where actually this is probably a good point to demonstrate what happens when you change the max sample count, because you'll see at the moment all the points on the plane are being dragged into specific points on the surface. Now if we increase this, then it's averaging that out and making it a bit smoother. The other way we could do this is increase the frequency of our sphere, which again gives it more points to work with, so it's not being pulled into very low res corners. Now if we grab our sphere and start moving it about, you'll see that this is affecting the colours and the shape of the object underneath, and you can create some really fun effects with this. Most of the time I use it for much more mundane uses, which I'll show you in a minute, but I thought it was interesting to show you some of the fun stuff you can do with it as well. Now I'm going to put together a little scene that uses the attribute transfer in lots of different ways. So I'm going to create a new geometry node. I'll turn that one off. And I'm going to create an L system. For now, I'm going to use almost exactly the default on this. So the L system, if you're familiar with turtle commands, the L system is a more complex version of that. So a turtle command draws a line and you tell it to go forward or left or right, and you can draw patterns with that. The L system has similar commands. If you look in here, you'll see there's rules, and you can build extremely complicated shapes. Tend to either be fractals or organic shapes. You'll find this sort of system is the basis of things like speed tree. It's very good for building vegetation. There's a huge amount to it, so we'll devote at least one tutorial to that at a later date. This is where we write the commands to give it instructions on how to grow. So in this case we start with FFF for forward, 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 and I'm just going to put a line before that which starts us off backwards, because we're going to be building the roots of a tree. In an ideal world we would be building the whole tree, but that's looking at some extremely complicated L systems. So for now we're just going to look at the roots. It's all we need for the purpose of this tutorial. And I'm going to stick in a transform node. And bring our tree up to ground level. There we go. Let's make it a little bit bigger as well. And I'm also going to create a mountain. So first of all, drop in a grid. Give it a lot more rows and columns, so we've got a nice detailed surface. I think I'll make it a bit smaller as well. And then add a mountain node to give it some shape. And let's make it just a small amount of hill. If we offset a bit, what we really want is a little hill in the middle of our mountain. There we go. And now we're going to use our attribute transfer. First of all, I'm going to stick in a merge node so that we can see everything at the same time. And then our attribute transfer. And it's the tree that we want to transfer the attributes onto, and we want to take them from the mountain. So we hook it into the tree and then connect it up to the mountain. And the attributes that we want to copy are the position. So we've just dropped the position of our tree down onto the mountain. And you can see it roughly sits on the surface. We still want a bit of trunk sticking up, so let's turn our distance threshold down. Here we go. Something like that. And I think I'll make the tree a bit bigger as well. If we turn points on, let's just go up to here, so we're just seeing the tree. You'll see the original tree had nicely evenly distributed points. Because it's pulled them down to the nearest point on the grid, they now have uneven gaps between them, and you're getting straight bits here that don't actually sit very well on the surface. So you've got a bit of a gap here. The easiest way to fix this, short of adding more subdivisions in the grid, which isn't a great fix and is expensive, is I'm going to do a remesh. a resample of the curves in our L system, and all that's doing is take the merge node out of there. All that's doing is rebuilding the curves and redistributing the points. So now you see we've got more points in here. Let's make the length a bit smaller. So there's more points to play with again. And we're going to do exactly the same thing again. So we've done a general positioning on the mountain, and now we can do a more precise positioning. So you see this time, if we add it to our merge node, the position of the what will become tree roots is now pretty close to the surface of the mountain. Now, when you're working with L systems, you have an option to give it tubes. But I haven't done this because the points on the tubes would also be snapped to the surface. So if you take a look here, you'll see it's building something a little bit more like a root system. But this doesn't work for us. So we'll leave it at the skeleton and then come down here. And instead of using tubes, we're going to use a polywire, which does a similar thing. It simply extrudes a tube along a polygon line. So let's put in polywire. There. You can see roughly what it's doing, and some settings we want to change. So we have our radius here, and we have some options for how it deals with joints. We can increase the number of divisions, which we probably want to do, and we can increase the number of segments, which we also probably want to do. Now, this doesn't look much like a tree because we want it to start thick at the trunk and then get thinner as it goes down. And there's a way we can do this. If we go back to our L system, we can turn on point attributes, and you can see this has created a whole bunch of new attributes which relate to different things within our system. The one I'm going to use is called Lage, and it represents the vertical distance from the root. So it runs gradually from the start out to the points of the branches. So if we look down here, you can see it gradually gets higher. Now if I click on it, you can see it goes from 0 to 1.2. So we now, as part of our polywire, have access to the L edge. There we go. So in our radius, I'm going to type which is not doing at all what we want. For a start, it's going the wrong way around. So I'm going to go back up here to before I resample, when everything is still quite neat, and I'm going to drop in an attribute VOP and use a ramp. Which is a ramp parameter. Drop this in, and we want our Lage value. So let's make a bind import node and put in Lage, which is a float, and we hook that up to the input of our ramp, and then we hook our ramp up to our color value, and then we can see what's going on. I'm actually going to do a fit range because we know that the highest value is 1.2, so we're going to make our source go from 0 to 1.2, and then we get the full range. The way that parameter node works is it automatically sends up to the top level and you edit it from here. So we have our ramp node here. We actually want this to be a spline ramp. And now if we go down to our polywire, we can start playing with our spline ramp, which is changing our color. To visualize it properly, we want it to output our lage value again. So let's go to bind export and hook this up. And again call this lage. And there we're getting something that looks a little bit more sensible. I think our values are probably still a bit high. You can see it's working here. I'm going to do another fit range at the end. And this time make our maximum destination a bit smaller, and we should be able to use more sensible values. There we go. It's probably not too far off what we want. The advantage of using a ramp here is you have lots of control of each part of it, and we can do things like make sure that our top is flat. Increase this just a little bit. I'm going to go back and play slightly with our first attribute transfer and see if we can bring the base down a little bit. No, it's going to stick it up. So that's going to be our trunk of our tree, and we'll just have to imagine that the rest of the tree is there. So now we can have a look at our tree roots sitting on the mountain. It's not great, but we're starting to get something that looks a bit like a tree. And the great thing about it is that it's completely procedural. So if we move the mountain, the tree roots move with it. So the next thing we're going to do is clean up our tree polygons a bit, because they're kind of a mess at the moment. And we're going to do this by converting them into voxels and then converting them back into polygons again, which will smooth out all the rough edges. This is something we'll look at soon, but for now just bear with me. We want to create a VDB from polygons. VDB is a sophisticated type of volume that doesn't draw every voxel in the interior, so it's a bit lighter and it's a bit more clever than a standard voxel. So here you can see we've created some fairly big chunky points for our voxels, and I'm going to make these much smaller. Now the smaller ones are outlining the ends of the roots quite nicely. You can see it looks a lot more tree-like. And then we go back again and we use a convert VDB node. And we tell it to create polygons. So now we're back to polygons again. Getting a little bit breaking there. Perhaps if we make this slightly smaller, it will fix it. Nope. Well, let's leave it for now because it's fairly dependent on the position of the tree anyway, and we're going to be moving it around. So here we have a tree. Only trouble is the voxels don't hold all the attribute information because we don't actually have any points anymore to attach them to. So we've lost all our attribute information, and we no longer have any UVs, which were very usefully created by our polywire. So you can see if we go into our vertices, we actually have UVs on our polywire, and we don't have them anymore. So we're going to do another attribute transfer to get our UVs back. And this time we're just skipping past our volume, and we're telling it that we want to transfer the vertex information. We're actually transferring the UVs. The distance doesn't really matter in this case because the two objects are in pretty much the same position anyway, and they should match up to the nearest point quite well. So we do in fact have UVs again. And while we're there, let's put a texture onto our tree. So I have a bark texture, which isn't great. The UVs created by polywire aren't fantastic, but they'll do for the purpose of this video. Now we're going to go back to our mountain and include that as part of our scene. So let's move the merged node down again. It would be nice to have a little bit of a shadow around where the roots are, so we're going to go the other way now. We're going to transfer attributes from the tree onto the mountain. So we'll first of all add in a colour to our tree. So let's stick it in here. Put in a colour node. And we also want to give some colour to our mountain. Something that you need to remember is that if you're transferring attributes, you need the attributes to exist on the original object as well, usually with a different value. So for example, if you're transferring a group of attributes that have a value of 1 onto a surface, then you would want to create an identical attribute with probably a value of 0 to already exist on that surface. Otherwise, the Houdini isn't going to know what you want in the positions that haven't had the attributes transferred. So we've created a colour node for the tree, and we're going to make that a shadowy colour. And we've created a colour node for our ground, which will leave it white. And then we stick in another attribute transfer. I'll do it before we do our shading. I'll leave the shading to the bottom on all of our objects. And let's hook up our mountain. Actually, I've gone the wrong way around now. So we actually want to go from We want attribute transfer to be on the mountain node, because that's where we're transferring the attributes to, and to come from the tree. So you can see immediately it's made all of the mountain dark, because it's copying all our point attributes. We only need one point attribute, so let's just stick that in so it's not worrying about anything that it doesn't need. And we'll take our distance threshold to 0 and increase our blend width. And now we can create a little bit of shadow around the base of the tree. And I'm going to stick a texture onto our ground as well. So you can see the shadow is still being displayed through the texture. So if we take a look at this, which for some reason isn't making it to the merge node. There we go. So now you can see the shape of the surface is influencing the position of the roots, but the position of the roots is influencing the colour of the surface. And the whole thing is still procedural, so we can still play around with our mountain and it moves to follow the surface. The next thing I'm going to do is stick in some vegetation. But before that, because things get pretty complicated, I'm going to use some colours to see what's what. So here we have our tree, and I'm going to make that brown just so we know which nodes belong to the tree. And then we have our surface, and I'm going to make that pink just because it's different from vegetation, which we'll be adding later. Now I want to, as we've seen before, scatter some points across the surface and create some ferns. So let's take our mountain node. We'll leave these two colours at this level because they relate to each other, and take another node off here. Just stick in a null to hold it in place, and then put in a scatter, and it's given us a series of points across the surface. And then we want to use a copy to points node to place our ferns. So these are the target points, and I have a fern object that I've already created, which is a very simple few planes with fern texture on it. So you can have a look at that here. And I need to hook up the texture again. And I'm getting blue tinting on the back faces, so you can turn that off in the display options. So here we have a fern object, and I'm going to copy that onto my points. So now you can see you've got a whole bunch of ferns sitting across the surface. And we'll merge that in as well. So the thing we don't want here is our ferns growing through our tree. So we want to clear an area around the tree roots where there's less ferns, which is what you'd expect anyway, because they won't be getting so much light around here. So we're going to do another attribute transfer. This time we're going to use a p-scale, which influences the size. So if we make a scale of 0 close to the tree, then we won't see those ferns. First of all, we need to set up our p-scale attribute, which, if you remember, is attached to the points and allows the copy to points to bring that value down and use it to scale the objects that it's placing. So after our scatter node, we'll drop in an attribute create node. You'll find you use this quite a lot if you're moving attributes around using the attribute transfer. So we create our attribute called p-scale, and you can see already they've disappeared because we give it we've by default got a value of 0, but we actually want the value to be 1. In fact, make it a little bit more interesting, let's use a small expression to give it some random scale. So let's say 0.5, because we want mostly to be round about 1, and then we'll add on a random value based on let's say at p.x. So now it's taking each point's position in the world and using that to generate a value, random value. You're very likely to have two points with exactly the same x position, so you get a nice even distribution. I think we've probably got too many points there as well, so I'll bring them down a bit and maybe make our stick a transform in and maybe make our ferns a little bit bigger. The other thing we might want to do is bring them down a little bit so that they don't look like they're all starting at a single point. There we go. So now we've got our p-scale, which is slightly randomized. If we take a look at our points, you'll see it goes from about 1.5 to about 0.5, which is exactly what we would expect. So we've got a value of 0.5, and then we're adding another value between 0 and 1. Now we want to transfer attributes from the tree roots again. So very similar to what we've just done here. We'll do another transfer attribute, and we want it to go in before our copy to points because we're actually copying it onto our points rather than our objects, because it's the p-scale coming in that we want to affect. So this is the value that is going through, and this is the value that we want to transfer. But at the moment we don't have a p-scale value, so it's doing nothing. So we'll need to make another attribute create and stick that on our tree just before it goes in. Let's line these up again so that you can see they relate to each other. And this time give it a value of 0. So the first thing that happens is all the ferns get a value of 0 because our influence is bigger than the size of the grid. So let's just reduce this to a single value again and makes things a bit clearer. So we're just transferring p-scale, and we'll reduce our distance threshold. Let's do a blend width so that they don't go straight to 0, they kind of shrink. Actually no, they look better if it's a hard line, I think. So now you can see all the ferns have been removed from around the roots and they're no longer intersecting. The last thing I'm going to do with this scene is place some leaves underneath the tree, and that's going to be done in almost exactly the same way as placing the ferns. Let's update these colours to see what's going on. So here I'm going to make these green because these are the ferns, and at this point where it's copied to the points it's also ferns. This is coming from the tree, so we have it coloured to the tree, and these points here are still part of the mountain, so we'll colour them as the mountain. It just makes it a bit easier to follow exactly what kind of geometry you would get if you were to look at each of these points. I'm going to bring in another file. Actually, I'll just copy this group across, and I'm going to make these red because they're autumn leaves. So this time I've got a piece of geometry called dead leaf, which is just a really simple little bit of geometry, and I'm going to attach a red leaf texture to it. And I don't want that transform anymore, at least not yet. So here we just have a really simple dead leaf, and once again we're going to create a scatter node. I can take it off the same null node, and we're going to create p-scale, but this time the p-scale for our surface will be 0, so get rid of this because we only want the leaves near the tree. So once again we create a p-scale attribute for our trunk, and this time we make it 1. If we have a look here, you can see the points, and we're going to want a lot more leaves. So ramp this right up. And then add our attribute transfer node. And then our copy to points node. We need to set this up before we start playing around with the attribute transfer because we can't really see what's going on yet. So we're copying to the points. Sorry, we're copying the leaves to the points. And here we go. And at the moment they all have a value of 1 because our attribute transfer has a large threshold. So let's drop this down. This time we possibly do want the blend width a little bit. And when we hook that up, you'll see that there's a very regimented collection of leaves sitting underneath the tree. Now, that's, as far as the attribute transfer node, that's us completed with this scene. However, it does need quite a lot of cosmetic tweaking. I'd like to see more variation in size and a bit more randomness, and some variation in colour as well, particularly in the leaves. So what I'm going to do is speed up the last bit of this video because it's not actually a necessary part of the video, but I'd like you to see how I do it anyway, so that when you download the file you know how I got to that stage. I'm basically going to add some materials rather than just sticking on textures, and then play around with some random values on the objects that I've placed, and probably play around with the tree a little bit to get something a bit nicer. So I'll speak to you again at the end of the video. So now we have our scene looking a bit better. I'll probably go back and tweak it a little bit more, but we're basically there. And the nice thing about this is everything is still procedural, though it's going to be a bit slower this time. So if we start tweaking our mountain, we should find that everything goes with it. And it's not just the mountain that we can edit, we can change. So if we go up to our L system, we can start playing about with some of the values here as well. Here we're making the roots of the tree a bit longer. And all our vegetation and leaf layout will adapt as well to keep everything in the right place. I can even scale everything up a bit. So you could see how you could quickly build up a forest of trees using this. That's nice and procedural. So that's it for the attribute transfer node. I hope you've enjoyed it. Next week I'm going to look at creating volumes, as you've had a quick preview of today. And there's lots of interesting things you can do when you're moving backwards and forwards between polygons and voxels. So I hope you've enjoyed this. Please subscribe, and I will see you again next week.